This is OChem with Ben. That's me! Eat that! Today, we'll be cooking carrots. Chemistry you can taste! Here's what you'll need. Carrots, 1 tablespoon butter, some water, about a tablespoon of honey, some salt to taste, black pepper, escarvone, one of the enantiomers of today. And the other enantiomer of today, arcarvone. Now that we have all of our ingredients, let's talk about enantiomers. What's an enantiomer, you say? Well, they're 2 molecules with the same connectivity but differ in spatial arrangement and are non-superimposable. So let's see which ones we're cooking with today. Right here we have escarvone and arcarvone. These do seem like very similar molecules, but in actuality, if you look closely, you can see that this group right here is facing away from us as indicated by the dashed lines. And over here, in arcarvone, the group is facing towards us as indicated by the solid wedge. Now, this may not seem like a big difference, but it actually leads to very dissimilar ingredients. For instance, right here, escarvone is the flavor of caraway seeds, whereas arcarvone leads to the flavor of spearmint. So put on your lab coat and goggles and let's get cooking! Remember, proper safety attire includes goggles and closed-toed shoes. Make sure to exercise caution when handling chemicals and/or equipment. Make sure you set yourself a lot of time for this experiment, as it takes a long time to do the preparation. Now you're done with the preparation. To begin cooking, melt 1 tablespoon of butter in your pan set over medium heat.
Sizzle, sizzle, sizzle. Paula Dane, y'all!
If you've ever smelt rancid butter, it contains butyric acid, a carboxylic acid derivative of an alkane. This, however, does not contain any of those carboxylic acids. Next, we're going to add some honey, a couple moles of escarvone. Make sure to give your solution a good stir so that your escarvone has a lot of surface area covered by the butter. Then add your pepper, and finally, add your carrots. At this time, it's okay to be hungry. Pour in some water and allow the solution to reduce until it becomes kind of syrupy. While we're waiting for our carrots to reduce, let's talk about enantiomers. Earlier, I stated that enantiomers have the same connectivity, but what exactly does this mean? This means that all the atoms are connected in the same way in both molecules. Now, if you watch closely as I switch these 2 groups, in the end, the connectivity is still the same. Now, about the non-superimposability. When you switch those 2 groups, these molecules actually turn into mirror images, which means that they cannot be superimposed upon each other, thus making these molecules enantiomers. Once the water has reduced, it should look something like this. And now you're done, just put it on a plate and serve. So what did we learn today? Well, we talked about the qualities that make 2 molecules enantiomers. Remember, that was non-superimposability while retaining the same connectivity. Also, 1 molecule cannot be an enantiomer. An enantiomer means that there's 2 different molecules that are related in this way. These 2 molecules, since they're enantiomers, have very different properties. Escarvone was caraway seeds and arcarvone was the flavor of spearmint. This small flip in the molecule led to macroscopic physical changes.